Assalamu alaikum dear students. Hope you are fine. You are utilizing this time in a productive way, and I hope you have understood the previous lecture very well. It was that opposite sides of a parallelogram are equal. Now in today's video lecture we will do the converse of that theorem. Converse is, now we are given that the opposite sides of quadrilateral are equal. We have to show that this is a parallelogram. In the first case we were given that if this is a parallelogram, ABCD is a parallelogram, then its opposite sides are equal. AB is equal to CD, AD is equal to BC. Now we are given that in this theorem that we have quadrilateral, not a parallel, we have quadrilateral, and we have these sides have been given, and we are given that these sides are equal. Now we have to show that this is a parallelogram. So in first case we are given parallelogram, we were supposed to show that opposite sides are equal. Now in the second case we are given quadrilateral, and it is given that opposite sides are equal. This thing is given. We need to show that this is a parallelogram. How will you do that? We can approach in a similar way, but concept of congruence is very important. So I recommend you, if you have any some difficulty or some doubt regarding the congruence, please go through the previous lectures which we did. If you still find any difficulty in this concept, please let me know that. So theorem is that a quadrilateral is a parallelogram if its opposite sides are equal. It is theorem 8.3. yes, a quadrilateral is a parallelogram if its opposite sides are equal. So this is converse theorem, converse 8.3. So what we are supposed to prove that a quadrilateral, we have to show that a quadrilateral is a parallelogram, but given that opposite sides are equal. So let's make the figure. A, B, C, D. Suppose this is a quadrilateral, not a parallelogram, and we are given that AB is equal to DC, AD is equal to BC. Now we will write the given as usual. Given a quadrilateral ABCD in which AB equals DC and AD equals BC. What we are given? A quadrilateral ABCD in which AB equals DC and AD equals BC. To prove, 3 steps you know. To prove ABCD is a parallelogram. To prove this theorem, we will do construction join AC. We will join this. Join AC. Now we have to prove that this is a parallelogram. How will you prove that? Recall the previous concept that if you are able to show that here, if you look carefully, if this angle equals this angle and this angle we can show that equals this angle, then clearly this line is parallel to this line and this line is parallel to this line. By that concept, recall that if the alternate interior angles are equal, if a transversal intersects two lines and such that alternate interior angles are equal, then lines are parallel. It is in the lines and angles, that concept we will use here. But we have to show that these angles are equal. How can we show that? We use the concept of congruence. We will write the proof in triangles ACB and CAD. In triangles ACB and CAD. So how I look at how we have to write the name, put the corresponding vertex as it at its place. It is ACB. Look here, when we will prove that these triangles are congruent, so vertex should be according to its corresponding vertex, because B corresponds to D, this corresponds to this. Now we will write, we will make them congruent. We will write AB equals DC. Why? AB equals DC. Why? Because this is given. AD equals BC. These things are given. And AC equals AC. Why? Common. So by what criteria we can say that these triangles are congruent? It is what? It is SSS. By SSS, I'm sorry, we will write it here. By SSS, triangle ACB is congruent triangle to CAD. Now we have proved that these two triangles are congruent. Let us give the number here: angle 1, angle 2, angle 3, angle 4. So when corresponding angles are when two triangles are equal, what happens to the corresponding parts? Corresponding angles are equal, corresponding sides are equal. So therefore angle 1 equals angle 4, angle 2 equals angle 3, angle 1 equals angle 4, angle 2 equals angle 3. Why? Because CPCT. Now have a look. We can, from here we can easily conclude that these are equal. So we will move further, but before that you pause the video to note it down. I'm sorry, I have the unavailability of the space here. So have a look. If you look, if we consider this if consider this angle 1 and angle 4. Consider angle 1 and angle 4. Angle 1 and angle 4, these are alternate interior angles, is it? But you know, when alternate interior angles are equal, then lines are parallel, then AB parallel CD. If we consider this AC transversal to AB and DC, and we have proved that angle 1 is equal to angle 4, that is alternate interior angles are equal, lines are parallel. I will show it here. You know that if this angle equals this angle, these are alternate interior angles. Recall that concept that we had proved that there, then these two lines are parallel. Same is the case here. If the angle 1 and angle 4 are alternate interior angles, and by we consider AC as transversal to AB and CD, then angle 1 is equal to angle 4, and these are alternate interior angles. So we will write now AC intersects AB and DC. AB and DC means AC is transversal to AB and DC, and we transversal in such a way that angle 1 is equal to angle 4, and angle 1 is equal to angle 4. Why? Because we have proved it here. So AB and DC are two lines. AC intersects them such a way that angle 1 is equal to angle 4. But what kinds of angle these angle 1 and angle 4 are? But angle 1 and angle 4, we will write it in one way, but these are alternate interior angles. And when alternate interior angles are equal, lines are parallel, and we know that when alternative interior angles are equal, lines are parallel. Lines are parallel. This concept we have read it before. Now therefore AB parallel DC. AB parallel DC. Similarly we will prove that we can prove that AD parallel BC. How? Similarly we can prove that AD parallel BC. Simple. Angle 2 is equal to angle 3. Consider this as transversal, and angle 2 is equal to angle 3. These are alternate interior angles, so lines are parallel, therefore AD parallel BC. Now we have showed that AB parallel DC, AD parallel BC. You know, a quadrilateral is a if opposite sides of quadrilateral are if a quadrilateral is a parallelogram, if its opposite sides are parallel. We have proved that opposite sides of a quadrilateral are parallel, so this is a parallelogram. This was the, we will name this one, name this second, from first and second, this is first, this is second. ABCD is a parallelogram. Why? A quadrilateral is a parallelogram. Recall the first lecture. A quadrilateral is a parallelogram if its opposite sides are parallel. So this was the theorem, all about today's theorem. I hope you will get it. If you still find any confusion, any doubt regarding this concept, please let me know that. Thank you, class.